All right, you guys ready, spaghetti? Exponential growth and decay. So you're gonna use a calculator for all these questions, pretty much all of them. I want to show you a little intro here. This should be a bit of review for you, okay? There's a famous puzzle where you go, you can set it up however you want, but like there's I think the way I first heard it was like, you listening?
Yeah.
I missed this. It's like the peasant goes to the king and says, "King, we need more food. Give us some rice or something." The king's like, okay, fine. I'll send you a big basket of rice. He's like, how about this instead? How about the king? The king's a jerk. So
I know this.
The smart peasant guy goes, well, I see you got a chessboard over there. What if you just put 1 grain of rice on the first square, and then you put 2 grains of rice on the second square, and then 4, and then 8, and so on. And then I'll just take the amount of rice that we end up having on the chessboard. And the king is like, well, okay, fine. I was going to give you a big old barrel of rice, but sure, I'll do that. So the king was a silly man, right? Because
Stupid.
think about, let's say this is the square number, and this is how much rice is on that square, right? How much, so on the first square, there's
1.
1. And to keep things simple, I'm actually going to call it the 0th square, actually. So call the first square you put on, just call that square 0. And then how about square 1? There's going to be now 2 grains of rice. And then square 2, there's 4, 8, right? 16, 32. And the question is, well, there's 64 squares, so I would end on the 63rd. How much rice is going to be on that square? So anyway, this is an example of exponential growth. So let's look at a formula here. So like this first one, how did I get this 2? Well, if you think about this 2 and this 4 and this 8, like these are all powers of 2. So, and you're always going from the previous number to the next number. So like this one, for example, is 2 to the 0. This is 2 to the 1. Now this guy is the previous number, 2 to the 1 times 2. So 2 to the 2, 2 to the 3. You get the idea?
Yep.
2 to the 4.
So it's just 2 to the 64th?
2 to the 63rd, the way we wrote it. So boom. How big is that number? Well, if you ask a calculator, how big is 2 to the 63rd power? It says 9 times 10 to the 18th roughly, which 18, which would be 9 with, so roughly speaking, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we have not just hundreds, not just thousands, or millions, or billions, or trillions, or quadrillions. We have roughly 9 quintillion grains of rice. Which
Thanks, Colin.
I'm not sure. I think I'd be willing to bet that's more
In a
than
barrel?
actually exists. Well, it's definitely more than a barrel. It's probably more than there are grains of rice on the earth.
Didn't the king then like kill him?
Yeah, the king just kills him. I don't know. It's just a made up story.
It's not facts and logic.
Facts and logic. Okay, so we're gonna take that idea. That's a little bit more of a basic exponential growth. Okay, you might have seen that last year. You might have seen it before that. We're going to combine that with this other fact. You shoppers like me may will know this one if you shop in whitefish.
Oh, tax.
What is the sales tax in whitefish? Is it
It's
3?
like
Is it 3? Okay. What? What did he say?
obviously he doesn't pay attention.
Yeah, there's sales tax in whitefish. You only notice if you buy something expensive, but when you buy something that's like $1,000, you're like, what? $30? It's like a little annoying. Is it really just 3%?
Here, I'll look it up.
Well, actually, that'll work great. So let's say you buy something. Here's some really basic math for you. Don't feel bad if it slips your mind here. You should know this. You're going to go buy a $80 sweater. It's Fuji. Supreme sweater. But Whitefish has a plus 3% sales tax.
Oh, no.
The question I want you to answer is how much are you gonna have to pay for it?
Oh, I got it.
Oh,
Okay,
no.
it's like,
You hopefully can get, don't say the answer. Hopefully, I'm gonna have to dig deep into your mind there. Remember this one.
I got it.
I got it too, May. Do you want to compare?
That's not what I got.
What's the answer?
I got 80-24.
82.4.
Yeah. Wait.
No, it's 82.4.
82.4. That's what I meant. I didn't add it on. to it.
$82.40 should be the answer.
Yeah.
We were having an argument in Josiah's class about sales tax, and someone was like, "Oh, so my $5 coffee will be like $7." I was like, "No, it's gonna be like $5 and a couple pennies, like or a couple cents." What was their argument? That doesn't make sense. I know.
Exactly, that's what we're-
That'd be like a 40%.
Yeah, that would be awful.
What if
It
there's
is
a,
interesting. I mean, it's a regressive tax technically, so I mean,
isn't there one in Sea called?
the more money you have, the less it affects you. It's kind of interesting. So
I want to be an Aristocat.
That's
do
nice.
whatever you set your mind to, you may.
Before you-
Okay, so the calculation. Watch this. This is the important thing. This is the important thing. The calculation is you have to
Yes,
go
I love that movie.
80 plus 80 multiplied by 0.03. And maybe, I hope some of you guys are thinking, wait a second, that's not how I did it. I just took 80.
Times 0.03 plus 80.
Okay, so,
But hold on, just give me a second. Do you agree with that?
yes.
So you agree that, did anyone just know that you can just multiply 80 by 1.03?
That's what I did. Yeah.
Okay, good.
Wait, why?
Behold. I think everyone agrees that this is how you calculate 3% of 80, and then you have to add that onto 80. Now, we know some algebra, we know distributive property and all that stuff. So we know that you can factor out this 80, right? Have 1 plus 0.03 inside, right? So therefore, I'm kind of proving to you that this is a valid thing. It's not just a funky trick, right? You can, if you want to add 3% onto a number, you can just multiply the number by 1.03. This is really critical to understand this. With me here, Caleb? Don't miss it. Do we understand that?
Yes.
Okay, so I'm gonna combine this idea with this idea. You ready?
It's a nice.
And we're gonna answer the first question.
Compounded annually. What?
Okay, so Alice is gonna put 35 hundos in this account that gets 9% annual interest.
Wish I had money.
Compounded annually means this. Means once a year, they calculate 9% of what your balance is and add that onto your account. Okay? Now you can probably already think, is that like, kind of sucks, doesn't it? You gotta wait the entire year before you earn your interest, right? Maybe?
That doesn't really bother me.
No.
Well, there's a reason why that doesn't really exist much. It's more like when you borrow money, imagine if they didn't charge your interest until the end of the year. I borrow $1,000 and they go, well, at the end of the year, we're gonna add on 5%. You could go 11 months and then just pay it back interest free. Right, so what they actually do in practice is they add on tiny portions of your interest every day. Usually it's once a day. I'm gonna show you how to calculate that. Okay, Alice. Let me make a little table of values here. You ready? Here's time. Here's Alice's account balance. B for balance. How much does she have at time 0 when everything starts?
3,500.
3,500. Good. Okay. Now, after 1 year, how will I calculate how much money she has after 1 year?
3,500 times 1.09, right?
Uh-huh. Does everyone feel okay about that?
Yeah.
How about after 2 years?
Well, wouldn't it just be 2 times that?
Close. Aren't I going to take this thing? So this is the amount I have in my account, right?
1.09.09.
And I would multiply that by 1.09 again, right? Because I, does
Okay.
that make sense?
1.09 squared.
Oh my God, Cohen.
Oh, I got it. I figured it out.
How about after 3 years? I would take this amount and I'd multiply it by 1.09 again. So
So is it like 3,500 times 1.09 to the power of x?
Close. Well, yeah, t, not x.
T, okay.
I mean, technically you could use an x, but you'd be weirdo.
I like it better that way.
I do too.
So at some general time t, you're gonna have. All right, do we feel okay about that?
Yeah.
Yep.
Okay. So that's her formula, would be her balance as a function of time is 3,500 multiplied by 1.09 to the t power. Okay, dokie? Now, how long will it take her account to hit $14,000? What do I do?
14 equals
Set it
35.
equal
Yeah.
to,
Yeah, the question we're asking is when will the balance equal 14,000? That's a question you can ask, right? So write this formula, which is our formula for her account balance, set it equal to 14,000.
It'll be,
First step to solving this,
Divided by 35.
divide both sides by 3,500. So you should have 1.09 t to the t equals 4.
Yep.
Oh man, if only there was some way to figure out
logarithm.
what number would I have to raise this number to get 4? Oh yes, logarithm. It's great. So we go log base. What's the base of our log?
109.
No, the base is 1.09
That's what I mean.
of 4 equals t. So now here's where your quackmulator
Yeah, I don't know if mine does.
it's gonna matter what kind of calculator you're using. So does anyone, this one will really make me happy if anyone can remember. There's a technique, the old school technique, in the good old days. How would they have calculated this?
Wouldn't they do like,
oh,
How do you get it to go down?
there was a chart.
Back in the
Back in the day.
that's before me. I'm saying in my good old days when our calculators only could do natural log and log base 10. If all you have is Mime, does your pig calculator have a log button?
Yeah.
Okay, so
But
say you have
doesn't-
Mime's calculator.
Yeah, it only does base 10.
Yeah, Mime, it's got to have natural.
Well, it has a natural, but I don't know how to get it to go to 1.09.
No, so Mime's calculator has an ln button and a log button. So I don't think you're going to have one that goes log base A of B. So what you could do is you could go log base 10 of 4 divided by log base 10 of 1.09. That's what I'm getting at. You could do the change of base. This is how I would have done it back in the golden age. So I will tell you how to do it on these though. And honestly, this is faster, but I'll show you
I was
anyway.
gonna say, that's easy peasy.
Pretty easy, yeah. Once you understand the change of base formula, it's extremely easy to just plug that in.
So it's log base 10 of 4 divided by log base 10 of 1.09.
Correct. Just make sure your answer makes sense. I'm getting roughly 16.
16.0864635 years.
Now, if you want to get really technical here, think about this. You guys know about my idol in life, Mr. Actually. Showing him, right?
No.
Yes, I have you, right? Haven't I?
You reference it all the time, but I don't know if you.
Mr. Actually?
Specific.
He's like my hero.
I know the Ice Ice Baby one where it's like,
Oh,
it's
no.
the same.
Oh, this guy. This guy's like my who I want,
Are
who I
you-
aspire to be.
Are you recording?
Yeah.
Can we to move the computer? Oh my god.
I've shown you him. This guy.
No, we haven't.
For the millions of Twitch fans. This guy. This is that's who I. Can you see him?
Yep.
This guy. He
Oh my god.
he goes.
Can you see Aslan?
So what he does is when you tell him, oh, it's going to take 16.09 years, he says, actually. And then what does he follow that up with?
No, it doesn't.
For years and days.
Think about the question. Her interest compounds annually. It compounds once a year.
Oh, it's gonna be 17 years.
Yeah.
Why?
He would say, well, actually, after 16 years, what he would say is, he'd say, well, this interest only calculates once per year. So on year 16, if I continue my chart, on year 16, she'd have 3,500 times 1.09 to the 16th power, which is actually only $13,896.07. And then on the 17th year, she'd have 15,000.
Is that like, I feel like that's a really good interest rate.
9% is very strong. You're not going to find anything out there that goes, we're going to guarantee you a 9% interest rate. But if you have diversified investments and it's a pretty good stretch of years, you'll be good. Or if you have riskier investments and they just work out like a little bit in your favor, you could get a 9% rate without being too risky.
Interesting.
If you play a super risky strategy, you can get gain rates of thousands of percent. It's just how lucky do you get? But anyway, so we're not going to nitpick too much. But do you see what I mean? How technically her account never actually reaches 14,000 exactly, but it exceeds 14,000 in the 17th year. So for your quizzes and stuff, you're just going to be expected to get a number like this. It's not going to be like. I'm not going to try to
I'm
like.
not gonna actually.
I'm not going to try to trick you and be like, oh, actually, it said it was compounded quarterly, so they don't actually get hit their balance until March or something. And also, pretty soon we're going to start talking about just continuous growth. So what happens if the thing just grows smoothly, not
All the
at
time.
set intervals? So, okay, that covers the basics. Now, number 2 is already talking about what if you want to compound your interest monthly? What happens then?
Well, then it compounds monthly.
So it's a little bit different.
Duh.
Good point. Good point. That's like some of the answers I get when it's like, this figure has perpendicular diagonals. What shape is it? It's a square because it's a square. Oh, okay, good reasoning.
That's like Caleb's frequency answer today.
Oh, the frequency is how frequent something happens. Yes, correct. Okay, so Bob, there's actually a very simple trick to this. Bob invests $10,000. Mr. Bob, there you go, $10,000. He's getting a 6% annual interest rate, but it's compounded monthly. So what does that mean, first of all?
So divided by 12.
60 divided by 12, right? Is that what you would do?
Where do you get 60 from?
6.
Like, oh, I was thinking like just because of like long division doing that in my head, but like so like 0.06 divided by 12, right?
Right, yes. Because one thing you could do, like I'm saying, if you were a bank, you could say, well, you're going to be getting, 6% of 10,000 is $600. So what if I just took that $600 that you were going to earn and then just give you to you in installments, 12 installments, right? Of $50 a month.
Yeah.
But you would the customer there would rightfully complain and say, wait a second, though, if you do that, I'm actually making less money, less interest, because what's going to happen in 1 month, I'm going to earn a 12th of 6%, and my account balance will actually be slightly higher, right? It'll be $50 higher. So then in February, the next month, I should be earning interest on that higher amount, right?
Right.
Here, I'll show you how it calculates out. We'll compare. So the trick is you go, well, I'm going to go 1 plus not 0.06. I'm going to take my 0.06.
Is it 0.05?
And divide it by 12. And that'll turn out to be 0.005.
And can I just write it as like 1.005 or do I write it like that?
We'll start with this. You would probably want to refer back to this later. Because the general formula, I'll show you that in a second. It's going to have a number there. Now, here's the thing though. What is the exponent? Keeping in mind that t, we always want t to be a number of years.
Okay.
There's very
so
few exceptions to that.
Would it be
in
like
dealing with money. At least.
1/12 T?
Let's think. Let's say it's been 5 years.
Okay.
How many times did we compound the interest then?
60?
60 times. Or let's say it's been 10 years. 120. So here I actually want to have 12 times t as my exponent. Does that make sense?
Yeah.
So t being the number of years, so the number of compounds that occurred. Again, it's a compound at this low rate. So the way this reads is 10,000 times 1.005 to the 12t power. And so there's my account balance as a function of t. Do we feel okay about that? Are there any questions? By the way, looking at this, you can figure out the formula is, do they have another word for this number? It starts with a P. No one? That's fine. Principal. Principal. Principal is like in this context, it's the amount of money you start off with. When you guys take out a loan, the principal is how much the loan you took out. And then every time you make a payment on your loan, what they do is they apply some of that payment to interest and some to principal. What you're going to find is they're calculating interest either every day or every month, and so your payment has to kind of simultaneously take care of the interest from that month and also pay down the principal.
So R is for rate.
R is like your annual rate. So in this problem, the R was 6%.
What does N stand for?
What do you think?
Net. Oh, like just time.
No, it's the number of times.
Number it's compounded.
Yeah, number of times we compound per year. That makes sense? So let's say you're compounding quarterly. What's N?
4.
4. Let's say you're compounding daily. What's N?
365.
How about say you're compounding weekly?
52.
So we all get that?
Yeah.
Okay, so to answer part B on number 2, what you do
Why not?
is you set this equal to 20,000. And what's the first step to solving this?
Divide by
10,000.
Divide by 10,000. And by the way, here's some food for thought for you. Look at that. Do you see?
Mm-hmm.
Bob is investing a modest $10,000. His friend invests $10 million, assuming the same rate. Who's going to double their money first?
The first guy.
Wouldn't be the same.
The same, right? Because if you put 10 million and 20 million, wouldn't it still just divide out to 2 and have the exact same equation?
Yeah.
That's kind of interesting. So Bob's going to earn $10,000 profit. That's good for him, but his friend is going to earn $10 million profit. So,
I would like a $10 million profit.
yeah, but the math tells us that yes, you proportionally it's the same, right? But the more you start off with, the more net gain you're going to have in terms of like the actual increase.
That would never work.
What's the solution? So how do you solve this? What do? You go.
It'd be log 1.005 and then 2.
equals
Equals
12t. So your calculation is going to be calculate that and then divide by 12. Do that on your calculator to see if. Oh, and I didn't tell you, if you're using a TI and you'd rather just type this directly in, go to the math menu. Do you guys see the math button? And then scroll down to the bottom where it says log base. It's kind of handy actually. You see where it says log base? And when you press that button, the calculator should display this. Did you guys get it to do it? So you can type in directly 1.005 and 2, okay? And it's gonna spit out, it's gonna spit out I want you guys to tell me what the meaning of this number is. This number, when I punch into the calculator, said 130, I'm gonna call it 139. What is the significance of that number? 139.
That's how many months it was.
Beautiful, yes. That's how many months it's gonna take. Well, you gotta divide by 12. So you get the answer.
So it'd be 12 months, right?
What?
Like, it's like, or I mean 12 years, sorry.
Roughly 11.58 years. But here's the thing though.
But then isn't it the same?
It'd be 12.
This would work out. I'd say he's compounding every month. So this says
yeah.
roughly 11 and a half years. So I'd say somewhere in July, maybe, could be, you don't have to get that precise. I
Probably
mean,
more like August.
yeah, it's either July or August, one of the two. Because he's gonna get hit when his sixth month is over, when June is over, he'll have that sixth compound in that year. This isn't like an accounting class. If this were an accounting class, you'd be setting up a spreadsheet that actually just goes cell by
For some
cell.
reason, I keep getting 20.
We're more interested in the broader idea here of just how does this growth work?
Okay, wait. We want
Um,
1, right? Divided by 1.00.
This is kind of like.
I'd click enter first.
this is more like the theory
And
behind,
divided by 12.
I guess to do accounting, you'd have to know how to set this up in your Excel sheet. But
You divide them.
there's an interesting formula that tells you, so if you know, say, I'm taking out a $30,000
Oh,
loan
yeah.
at a 2% interest rate,
Oh, I'm dumb.
what size of payment do I have to make every month in order to pay that off in, say, 5 years for a car payment? That's what you do mathematically. It's like, you might.
It is a lot of money.
Yeah, I agree.
Do you have a $30,000?
You've seen my car.
No. You're-
I drove a new car once. I'm just a person that places no value really in driving a shiny new car, I guess. But there is a trade-off of reliability at a certain point. There's some sweet spot of there's an argument to be made for you buy a new truck, you get the warranty and you're kind of guaranteed that it's going to be covered. It just depends on what you can afford. If you make a lot of money, then $30,000 car, your car payment's just who cares? It's like my Netflix. I'm I don't care. Even if I'm never too bothered by my Netflix. Yeah. So when someone who makes a lot more money might feel the same way about their car payment on it. Because a $30,000, that's sort of almost an entry level amount for buying a new truck, right? You're gonna have a hard time finding a brand new truck for less than 30. But anyway. Okay.
We should do 30, just so